So today we're doing 5-5 function operation. I'm going to tell you right now your homework is going to take you so quick. It's going to be so quick. You might even want to start on tomorrow's homework so you don't have so much tomorrow. Which tomorrow's is what, a whole 11 problems? Okay, so you are going to actually repeat. You're going to see things as we go. Hopefully you already have. We're like, oh, we used that earlier in the year, or we did this early in the year. So we're going to add and subtract and multiply and divide functions. Have we already done that?
Yes.
Yeah, we did that topic 4. If you looked at your topic 4 test, you were adding, subtracting, multiplying, dividing functions. That's what you were doing. Now I'm going to put them in function notation. That's all I'm going to do. Tomorrow we're going to add composition to it, but today that's all we're doing. So you could do today's homework and part of tomorrow's. That's up to you though.
Wow.
I don't want to overestimate your abilities or ambition. Okay, so what I have up here is I have f is 3x plus 4, and I have g is x squared minus 5x plus 2. So f of x means that's a function, right? If I would graph it, it would pass the vertical line test. 1x, as for every x, there's only one y, right? That's all that stuff means. So when you see something in function notation, it should like clear up the world to you and what you're going to expect to get out of this thing. But instead of saying 3x plus 4 plus x squared minus 5x plus 2, I've said what here?
F plus G.
F plus g. What's that mean to do?
Add F
Add f plus g. That's all it means to do. Okay, I can write it like this. I can write it like this. I can write it like this. Does any of that mean anything different?
No.
No. When I add the x, it just tells you what's the variable.
X.
X. The variable is t. What would all those x's be?
T.
T. All it does is mean add it. So you have 3x plus 4 plus x squared minus 5x plus 2. So what do I do?
Combine like terms.
Combine like terms. I don't have to do anything with that plus in the middle.
Nope.
No, because you distribute it, right?
Yeah.
And when I distribute a positive, does it change anything?
No.
No. So I just combine like terms and get what?
X
X
squared minus
2x plus 6.
Okay. So have you done this before?
Yes.
Yeah.
Yes. All I'm doing is now saying their functions. That's it. Okay. No, I didn't say solve. If I did say solve, you'd factor so it equal to 0, right?
Yes.
Can I factor the factors of 6 and add to 2?
No.
No. So I can't factor, so if I had to solve it, I'd have to use the what?
Quadratic formula.
Quadratic formula. So all those things should be going in my brain, but did it ask me to solve?
No.
No, so I don't have to do that. Okay, what happens if I did g plus f? Would it change my answer?
No.
No.
No, because addition is, does anybody know that word?
It's commutative.
Commutative, okay?
Go.
Addition is commutative. I can say f plus g or g plus f and I get the same thing, wouldn't I? Is subtraction commutative?
No.
No. So I'm going to have f minus g. So I have 3x plus 4 minus x squared minus 5x plus 2. I want a hand for what I need to do next. Garrett.
Well, you would keep the x squared because there's only the x squared on on one side, but you would subtract 3x from 5x and get negative 8x.
You're forgetting something. Ethan.
Distribute your negative.
He's forgetting distribute is negative. Okay? Once I distribute the negative, is it any different from the other problem I just did?
No.
No. So I distribute this negative, so this makes it a negative x squared, a positive 5x, and a negative 2. And then I do what? Combine like terms. I'll scribble out that.
So does the negative in the middle turn to positive?
Well, I just make it one big negative sign. We don't do plus negatives anymore. Just one big negative sign. Okay, so now what do I have? Garrett?
Would you have negative x squared plus 8x plus 2?
Yes.
No, it would be minus 2.
No, it'd be plus 2. Okay, is that what you had the first place?
Yes.
No, Garrett. Did you have that the first time, or did you not write it down?
I did not write it.
Okay, So I wondered if maybe you did it right, but we're just saying it wrong. But we have to do what before we combine like terms?
Distribute.
Distribute the negative. We have to. That's the difference, right?
Yeah.
So I want you guys to do G minus F.
G minus F.
Did you guys get it?
Not yet.
Not yet? Okay. Did you get x squared minus x minus 2?
Yeah.
Okay. Lena, did you get that? Okay. The biggest mistake people make. The biggest mistake people make is not distributing the negative to the whole thing. They'll usually get the first term, but then what do they forget to do?
The second and
Every
third.
term, right? When we distribute, we have to distribute to everything in the quantity, don't we?
Yes.
Now, could I do this with 3 functions? Could I do it with 6 functions?
Yeah.
Could I do it with 38 functions?
Yes.
So I can continue. Now, can you see why it would be helpful to do things in function notation rather than write them all out? Yeah,
Yeah, it's
Um,
right.
it would be a pain, right? So, I have 2 more. Would you like to do them all on your own?
I'll
Yeah.
try.
Okay. So you got F plus G and F minus G. So nothing new here, right? Just how I write it, the problem?
No, ma'am.
Now I'm going to tell you in the book it says something like write the rule. Just do it. That's what it means. Just do the problem. Just add and subtract.
Is that like Puma's logo?
No.
What?
Phil, are you okay?
Okay.
did I ask you?
Good on that one?
Yes.
Thumbs up? Okay, Isaiah, what'd you get?
2x squared plus 9x minus 4.
Okay, do you guys agree with 2x squared plus 9x minus 4?
Yes.
Yes. Oh.
I don't.
9x. Oh.
I agree.
Okay, did anybody do f minus 2x minus, did you not?
What?
Did anyone not notice that I switched f and g around?
I did.
It took me a second.
Okay.
No, I did not at all.
Well, I'm hopefully nobody made a mistake. Last hour when I did you make the mistake?
So wouldn't
Oh.
that be a negative minus 9x? Because
Um,
the negative, their G.
no.
Oh, you got
That's what I just said. That's, okay, when I did this last hour, I wasn't paying attention and I just wrote the answer. And guess what I didn't do? I didn't look. I didn't look at the names.
You weren't paying attention.
Okay, I wasn't paying attention. So be careful because when I do subtraction, doesn't matter which order I'm in.
Yeah.
Yes. Now the addition, it didn't matter. I got the same answer, didn't it?
Yeah.
But that subtraction would give me the wrong answer. So just be careful of that. So addition doesn't matter. Subtraction does. What else matters?
Division.
Division matters, right? Does multiplication matter?
No.
No. Okay.
I have a question.
Yes.
See, when you're subtracting, like if you have g minus f, g minus f,
Okay, so if I had g minus f,
wouldn't that just be negative 2x squared minus 9x plus 4? It would just
g minus f, so it'd be negative 2x squared minus 9x plus 4. Yeah.
So it's pretty much just the same answer.
You just switch the numbers.
Yeah.
Yes. It should be.
Should.
Should. Not like.
Let's be rude.
Okay.
Oh.
So this one also says divide, and this is the only slide I have on division. And I didn't have anything on multiplication, and you have a multiply in there. But what do you do when you multiply functions?
You just distribute.
You just distribute, you FOIL, you do the box, right? Okay, so if division, how do you think they would write division?
Will they write like F
Like a-
over G or
F
G
over
F?
G. We could write it like that. We could write it as f of x over g of x. Or we could write it as, this one's really weird, but you will see it.
Huh?
It's just f divided by g of what variable? X. Okay, so how do you think multiplication would be written?
F.
Well,
F
times
g. Or you could write it f of x, g of x. Or you could write it f g of x. Okay, so you can write it all of different ways. We'll do this last one. We'll do the last one, multiplication. How about that? We'll do division on the top two.
Okay.
So the first one we're gonna do f divided by g. So I got x minus 7, right? Okay, and it's just gonna be over 2x squared minus 13x minus 7. But we know how to do this, right? We know we probably should reduce, correct?
Yeah.
So how do I know if I can reduce? What do I have to do?
you could. Well, you've got like terms. You got -7, -7.
That don't work, G.
Why doesn't that work?
Well, because I just know it doesn't. Because I didn't do good on the test.
Because you yelled at us.
Yes, I yelled at you when you did it.
Because it's
Because
not.
this is
Because they're
what?
quantities.
They're not the
They're
same.
quantities.
Damn.
Yeah, they're quantities, yes? So what do I need to do to that denominator?
Multiply by it.
You need to reciprocate. Well, not reciprocate.
Are you having like a stroke or something?
What?
It starts with C.
Nope. It's one of your F words.
Factor.
Factor.
Oh.
Wow.
Okay, so I have to, it's quadratic, I have to factor, yes?
Yeah.
It's already a fraction, so the other one is factor, right?
Yeah.
So we need the factors of 14 that have a difference of 13.
So.
1 and 14.
1 and 14. Yeah?
Yeah.
Okay, so we're going to practice this factoring with not 1. Okay? So the factors of A go here, yes?
2x.
Yes.
So 2x and x. Remember this and this gives me my 14 and 1. So 2 times what is 14?
7.
7. And so this has to be a
2.
1. Because 1 and 7 are the factors of 7, yes? And it's going to be negative 14, so the 7's negative and positive 1. So now I have x minus 7.
And then those can reduce out.
So these can reduce out, yes?
Yes, so it's just.
So it's just 1 over 2x.
Plus 1.
1 over 2x plus 1. Now, domain. Now, if you need to, if you need to do the factoring by grouping and you need to put the 14 and the x and do the grouping, I don't care. Do what you need to do, right? But we're going to start when these things are prime, when like 2 is prime, we're going to start trying to get away from that a little bit. Okay, so domain, I have a fraction, so domain means I have some excluded values, yes? Where do I get those? How do I get those?
From the. Should we do
Whatever equals
all the
0.
factor? Factors. Whatever equals 0.
Set what equal to 0?
The denominator.
Denominator, because I can't divide by 0, yes?
So
And I need to come here, yes? Because even though it reduced out, it still can't be there, can it?
X is negative 1/2.
So x cannot be, subtract 1, divide by 2, so negative 1/2 and 7. Every time we have a fraction, we should worry about that, shouldn't we?
Yes.
Yes.
I have a quick. Are
What?
we doing that for, like, are we doing the whole list thing?
No, we're doing that, just that. Just that.
Not range or anything?
Not domain, not range, and we're not doing range, we're not doing asymptotes, but I should know that negative 1/2 says asymptote, yes?
Yeah.
Why isn't 7?
Because.
Because I reduced it out, right? So it's always good to remember those things and say, okay, I know we've done this before. What can I remember about what we've done before? Because that keeps it current, right? Keeps it twirling in our head.
Yeah.
So
See the 2x.
we're going to do G
It's just 7 equal to 0.
over F. Okay, what are we going to have to do with F, guys?
Factor.
We're going to have to factor, okay? So G is just what? X plus 3? Piece of hair tickling me somewhere. Factors of 18 that have a difference of 3, and we have 1, so that's going to be
6 and
easy,
3.
right?
6 and 3.
So x minus 6 and x
Mine plus
plus 3.
You can reduce those out.
I can reduce those down to 1 over,
X minus 6,
oops.
multiply x plus 6.
Okay, what's my domain?
Domain is x such that x does not equal 3, negative 3, and 6.
Elena, did I hear you say that also? Or was that Callie?
That's Kendra.
Was Kendra? Oh, one of you.
It was me. No, I said it.
Okay, what I want you to tell me, I want you guys to do F divided by G and tell me the domain.
Oh, it's just, yeah.
Shh, on the paper, not out your mouth.
Yeah. Out your mouth. Tell me the answer.
Is there a negative 3 for the top domain?
Yes. Taylor, what'd you get?
Isn't it x minus 6 over 1?
It's, yep, we're just x minus 6
Yeah.
because those would reduce out, right?
Yeah.
And what is your domain?
Isn't it the same thing?
Nope.
Minus
It's only x what?
3.
Minus 3. Why is it only x minus 3?
Because the denominator is x plus 3.
Yep, because when I reciprocate this, that x plus 3 is going to be the only thing in the denominator, right? And my numerator can be 0 all day. It doesn't matter.
How is it x minus 6?
Because it's going to be x minus 3, x plus 6 over x minus 3. And so these are going to reduce out. Remember, you have to go before you reduce.
Where are you using x plus 6?
We did
Oh, it should be minus. I'm sorry, minus. I put the wrong thing. I put the minuses and pluses.
Oh,
So it's gonna be f
that's-
times x.
What?
It's
you want f over g, right?
Yes.
So x minus 3 over x minus 3.
It would be x
two.
plus, it would be x plus 3, x minus 6 over x plus 3.
Wouldn't that be 2?
no, 2.
2.
Does
Wait,
he factor
no.
g?
Well, G is just x plus 3.
Oh, you want that one. God. I thought you were
Oh,
talking
you
about...
were doing this
Yes,
one.
I thought you meant
Oh, no.
God.
Wrong problem.
that one. Well, I got it done anyways.
Okay, good.
But we're doing it multiple.
Okay, we're doing this one. Okay. Now, we're gonna multiply this, so you're gonna multiply it, and I don't think I want you to do it, okay? You're gonna multiply it, does it matter, FG, how else could I get the same answer?
GF.
GF. So you're gonna do it, and you're gonna foil it, or you're gonna do the box, I don't care what you do.
I'm already done.
Okay, good.
I think I have it. I'm not sure.
Oh, I don't know,
Are you upset?
I don't know,
No.
I don't remember.
No, not for that.
Hey, did you get x cubed minus 4x squared minus 3x plus 18?
Yes.
I got-
Very much so. I'm too good at math.
Okay, so whether you foiled, you did the box, or you did my modified thing I do, you should have all got the same answer. Yes?
I did.
You did not. What did you do wrong?
um,
Unless I did it wrong. Did I get it wrong?
minus 3x.
No.
That's what I got.
And Evan's the most
I
trustworthy.
have minus 9x.
Yeah, do it on mine.
Okay, so this 3 right here should be a positive because you have a negative and a negative, so it becomes a positive. Okay, we have to remember those basic, like 5th grade integer stuff, right?
Yeah.
So it's gonna mess us up more than anything else.
Are we gonna actually go over multiplication?
No.
That's
she
it.
said we literally just did.
Do you want me to
I know
do?
you just
do
did.
Do you want me to do it again? What are you asking?
Yes.
Another, this one or another example?
Another example.
Okay, can we just multiply this up here?
Yes.
Yeah.
I guess.
So do you want me to do it, or do you want to do it and check your answer?
I want you to do is actually work it all out.
Okay.
Try to box, cause I like.
Okay, well, I was gonna say, this is my work. Callie, this is my work that I did. I foiled, I distributed this through here. That's my work that I did. You would like me to do the box, Taylor?
Yeah.
Okay. Now, when you do the box, I'm gonna do a 2 by 3. Cause I like my boxes to go long instead of tall, cause I don't like to use that, just paper space. But it doesn't matter, does it?
No.
So I'd have x cubed minus 3x minus 18x, 3x squared minus 9. That probably should be an x, huh? Minus 8, 4, 48, right? No,
54.
8, 4, 78, 4, 2, 54. Yes.
54.
Okay,
Good
so
point.
then I have x cubed, and then these zero out, minus 27x, minus 54.
Yes.
Okay.
Okay. Was that helpful?
Yeah, it seems easier.
Okay, when I do this, this is just a modified box. What I did here is I distributed my x, so I got x cubed minus x squared minus 6x, and then I distribute the negative, and then I line them up. So where here the like terms are diagonal in the box, here I just lined them up. So I'd have negative 3x squared plus 3x, and then plus 18. I like this because when I do my boxes, I get all, my head gets all involved and my boxes aren't even, it's not straight, and I'm messing with all that. I can make a modified box and just line them up. And if it's not a like term, I just skip it and line it up. Or you'll have them at the end. So, Elena, you do that, don't you?
What?
You
That's the one I do.
Is that the one you do? I knew somebody did all the time do that. I had a freshman one year show me that they were taught to do it that way, line up like terms like that. I'm like, that's pretty cool. I like that. Because the box, I do. Anybody else get caught up, like your boxes aren't the same size. It's squiggly. I'm the only one.
Homework, I just make a T.
Make a T.
Good man.
That works. Yeah, a T would be the same thing. So,
I like Devin's answer.
what?
I don't do homework.
Okay, so 6 problems today. Let's get it done and turned in before you leave.
How much
If
time
we
we have
can.